Hello there and welcome back to the Sleep Science. You find yourself hovering in a universe that is almost, but not quite, nothing at all. Space is warm compared to what it will become later, yet still unimaginably sparse, like a vast, dark ocean with only a few grains of salt dissolved inside it. There are no stars yet, no galaxies, no glowing landmarks to orient yourself by. Just darkness, gently humming with leftover energy from the Big Bang, as if the cosmos itself is still exhaling after a very dramatic entrance. You drift slowly, and time feels thick here, stretched and syrupy. This era is sometimes called the Cosmic Dark Ages, which sounds ominous, but it's really more like the universe is taking a long nap before doing anything impressive. A mainstream scientific fact slips quietly into your awareness. About 380,000 years after the Big Bang, the universe cooled enough for electrons and protons to combine into neutral hydrogen, allowing light to finally travel freely. That ancient light is still around you now, faint and stretched, destined one day to be detected as the cosmic microwave background. You don't see it with your eyes exactly, you feel it. Like residual warmth in a room long after a fireplace has gone out. You probably won't survive this with your eyes open. That's okay. The universe isn't in a hurry, and neither are you. As you float, you notice tiny variations, barely there ripples in density. Some regions are microscopically heavier than others, the result of quantum fluctuations magnified to cosmic scales. This is the quiet beginning of everything that will follow. Gravity hasn't built anything yet, but it's already making notes, bookmarking places it might return to later. A quirky tidbit drifts by. If those early density ripples had been even slightly different, the universe might have ended up completely smooth, with no galaxies at all, just eternal darkness and disappointment on a cosmic level. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. You continue to hang in the dark, and you realize that nothing is doing a surprising amount of work. Hydrogen atoms bump gently into one another. Dark matter, mysterious, invisible, and deeply antisocial, forms enormous halos, scaffolding the universe long before anything shiny shows up. You can't touch dark matter, but you sense its presence the way you sense furniture in a dark room by the way everything else moves around it. Historians still argue whether the first structures formed quickly in dense clusters or slowly in isolation, like lonely campfires flickering on a vast plain. The uncertainty doesn't feel stressful here. It feels appropriate. The universe itself hasn't decided what it's going to be yet. You imagine the temperature slowly dropping, the expansion quietly stretching space itself. There's a soft cosmic hiss, not a sound exactly, more like the idea of sound. You become aware of how patient all of this is. No explosions, no dramatic music cues, just slow preparation. If the universe had a to-do list, it would say something like, Step 1, wait. You invite yourself to relax into that waiting. You notice how the darkness isn't empty, but full of potential, like soil before seeds are planted. This is the long before, the deep inhale. Everything you know, stars, planets, late-night science videos, depends on this quiet stretch of time doing exactly what it's doing now. Almost nothing. Very carefully. You gently remember where you are in your own small corner of the cosmos, maybe under a blanket, maybe with a screen dimmed low. You're not required to understand everything. You're just here to drift. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You remain suspended in the same expanding darkness, but something subtle has changed. Time has passed, millions of years now, and gravity is beginning to clear its throat. Not loudly, not dramatically. just enough to be noticed if you're paying very close attention, which you are, because there's nothing else to do out here except notice. You drift toward one of those faintly heavier regions you sensed earlier. It doesn't look like much. In fact, it still looks like nothing. But this patch of space has a little more matter than its surroundings, and gravity, patient and persistent, is starting to lean in. A solid scientific fact settles gently into the moment. Gravity amplifies tiny differences over long periods of time, meaning even the smallest early imbalance can eventually grow into something enormous, given enough cosmic patience. And the universe, as you're learning, has nothing but time. You imagine matter moving, not rushing, just drifting inward. Hydrogen atoms slide closer together like sleepy commuters, gradually filling an empty train car. Dark matter halos deepen their grip, creating invisible wells that ordinary matter can't help but fall into. You can't see these wells, but you can feel their shape, like a slow dip in the fabric of space. This is gravity learning how to clump. No instruction manual, no rehearsal, just quiet trial and error on a universal scale. There's something oddly comforting about how inefficient it all is. Nothing snaps into place, nothing clicks. It's more like a very long, very slow group hug between particles that barely acknowledge one another. A quirky tidbit drifts past your awareness. If gravity were even slightly weaker, galaxies might never form at all, and the universe would remain a thin mist forever, an eternal fog with no lights to turn on. You float closer still, and the density increases just enough for warmth to rise. Not heat you'd notice on skin, but a gentle, energetic stirring, like a room warming by 1 degree over several centuries. Gravity compresses gas, and compression raises temperature. This relationship is simple, reliable, and deeply important. It's the universe's way of saying, if you squeeze things long enough, something interesting eventually happens. Historians still argue whether dark matter led the process entirely, pulling gas in behind it, or whether ordinary matter played a more active early role than we currently suspect. The debate feels distant and academic from where you're floating, but you appreciate that even now, with all our instruments and equations, some parts of this story remain fuzzy around the edges. You notice that space itself keeps stretching outward while gravity pulls inward. It's a quiet tug-of-war with no spectators, no referees, and no clear winner. Just balance, adjusted continuously. The universe is learning how to organize without ever stopping its expansion, which is honestly impressive multitasking. You feel your own breathing slow in response. Gravity doesn't rush, and neither do you. There's a gentle rhythm to all of this. Pull, drift, settle, repeat. If the first section was the universe waiting, this one is the universe practicing patience with intent. A soft, modern thought slips in. This same force shaping galaxies is also the reason you stay in bed instead of floating into the ceiling. Scaled down, gravity is still quietly doing its job for you, too. No applause required. You drift alongside these growing clumps a little longer, aware that they're not galaxies yet. Not even close. They're more like promises. Gravity has learned the basic move, and soon it will start repeating it everywhere. For now, you let yourself hover, content to feel the slow pull, the steady gathering, the universe teaching itself how to become structured, one almost nothing moment at a time. You drift onward, carried gently by gravity's slow choreography. And the clumps around you are no longer just promises. They're beginning to feel intentional. Gas is gathering more confidently now, pooling into vast clouds of hydrogen and helium that stretch for hundreds of light years. These clouds don't glow yet. They're dark, cool, and quietly ambitious, like ideas still forming at the back of a tired mind. You move through one of these clouds, and it feels softer somehow, denser, but calmer. The temperature here is dropping as the gas radiates energy away into space. That cooling matters. A clear scientific fact settles into your awareness. When gas cools, pressure decreases, allowing gravity to pull it inward more effectively. Cooling is what turns loose clouds into collapsing ones. Without it, nothing ever quite commits. You imagine the atoms slowing down, bumping into each other less violently, giving gravity the opening it's been waiting for. The cloud begins to fragment, breaking into smaller knots, each one a potential cradle for something new. It's not dramatic. There's no countdown, just a gradual sense that change is becoming inevitable. There's a strange intimacy to this stage. These clouds are enormous, yet fragile, easily disrupted by turbulence, by stray motions, by the restless expansion of space itself. A quirky tidbit drifts past. Some simulations suggest that early gas clouds were so turbulent that star formation nearly failed multiple times, like the universe repeatedly almost forgetting how to light itself up. You linger near one especially dense pocket. Gravity tightens its grip here, pulling gas inward, increasing pressure and temperature once again. This time the warmth feels different, not just compression but anticipation. You sense that this cloud is dreaming of stars, even if it doesn't know the word yet. The physics is simple, but the outcome will be anything but. Historians still argue whether the first star-forming clouds collapsed smoothly or chaotically, with violent internal motions tearing them apart even as gravity tried to hold them together. From where you float, it looks like a bit of both, order and mess braided together, neither one winning outright. You notice how long this takes. Millions of years pass like a slow yawn. If you're used to thinking of creation as explosive and fast, this stage gently corrects you. The universe prefers preparation. It prefers rehearsal. It prefers letting conditions ripen until action is unavoidable. There's a soft hum to the cloud now, not a sound, but a sense of motion everywhere at once. You feel eddies of gas, subtle rotations beginning to emerge. Angular momentum, conserved from tiny early motions, ensures that nothing collapses straight inward. Everything swirls, even in the dark. Even before light exists, the universe is already practicing its spirals. A quiet, modern aside floats through your mind. This is the same process that will one day form stars, planets, and eventually the elements in your own body. Right now, though, it's just gas getting comfortable with itself. You allow yourself to relax deeper into the scene. There's no rush toward ignition yet. This section of the story is about becoming ready, about clouds learning how to hold on, about gravity discovering that if it waits long enough, matter will eventually give in. You drift out of the densest region and look back. The cloud remains dark, silent, and full of intention. Soon, very soon, cosmically speaking, it will cross a threshold. But for now, it simply dreams, and you drift with it. Suspended in that almost moment where everything is possible and nothing has happened yet. You feel it before you see anything change. A quiet tightening, a gentle insistence. Deep within one of those dreaming clouds, gravity finally wins an argument it's been having for millions of years. Gas collapses inward more quickly now, and the temperature climbs steadily, no longer content to remain a background detail. You hover nearby as pressure builds, atoms crowding together like they've agreed, at last, to try something new. This is where the universe lights its first match. A solid scientific fact settles softly into the moment. When the core of a collapsing gas cloud reaches about 10 million degrees, nuclear fusion ignites, fusing hydrogen into helium and releasing enormous energy. That energy pushes outward, balancing gravity's inward pull. A star is born, not with a bang, but with a quiet, sustained glow, as if the universe has finally opened its eyes. You watch the first stars ignite, and they are nothing like the calm, long-lived stars you're used to imagining. These are giants, massive, hot, and short-tempered. They burn bright and fast, blue-white and intense, pouring out radiation that slices through the surrounding darkness. For the first time, shadows exist. For the first time, the universe can see itself. There's something almost rude about it. After all that patience, these stars arrive loud and overwhelming. A quirky tidbit drifts by. Many astronomers think the very first stars, called population 3 stars, were hundreds of times more massive than the Sun and lived only a few million years before collapsing. Cosmic overachievers, briefly impressive, then gone. You float at a safe distance, feeling the environment change. Ultraviolet radiation floods outward, heating nearby gas, stripping electrons from atoms, ending the cosmic dark ages in patches and bubbles of light. Space is no longer uniformly quiet. It has hotspots now, personality, drama. Historians still argue whether these first stars formed alone or in small groups, clustered together like nervous performers stepping onto a stage for the first time. The evidence is thin, indirect, and deeply debated. You find that uncertainty soothing. Even here, at the dawn of light, the story refuses to be perfectly tidy. The stars don't last. You can almost feel the clock ticking inside them as they race through their fuel. Fusion pushes outward, gravity pulls inward, and for a brief time, the balance holds. Then the hydrogen runs low, heavier elements begin to fuse, and the delicate truce collapses. Some of these stars will end their lives in spectacular supernova explosions, while others will quietly collapse into black holes, leaving behind scars in space-time. You notice how little time passes on a cosmic scale and how long it feels from your drifting perspective. Millions of years slide by like slow-moving clouds. The light becomes familiar, comforting even. You didn't realize how dark it was before until now. A soft, modern aside floats in. Every glowing galaxy photo you've ever seen traces its ancestry back to moments like this, these first reckless stars turning darkness into structure. Right now, though, there are only a few of them, scattered and rare, like distant campfires on a frozen plain. You linger as one star flares brighter near the end of its life, shedding material into space. The universe is learning something crucial here. Light changes everything, but it never lasts forever. Creation and destruction are already intertwined, even at the beginning. You drift onward, carrying that first glow with you, knowing it won't be the last time the universe surprises itself with its own brightness. You drift onward through a universe that now knows how to shine, but also how to let go. The first stars you watched so carefully are reaching the ends of their brief, extravagant lives, and they do not go quietly. Inside them, fusion has marched relentlessly toward heavier and heavier elements, squeezing energy from matter until the balance finally fails. Gravity takes over again, decisive this time. And the star collapses before rebounding in a tremendous release. You don't hear the explosion, but you feel it, a ripple through space, a sudden enrichment of the surrounding darkness. A mainstream scientific fact settles gently into place. Elements heavier than hydrogen and helium, like carbon, oxygen, and iron, are forged inside stars and spread through space by supernova explosions. Without stellar deaths, the universe would remain chemically simple and profoundly boring. You float through the expanding debris. It's warm, energetic, and messy. Nothing like the calm clouds from earlier. Atoms that never existed before are now tumbling through space, colliding, cooling, mixing. This is the universe discovering complexity, one shattered star at a time. You imagine the irony. Creation depends on destruction, and the cosmos seems perfectly fine with that arrangement. A quirky tidbit drifts by. Some early stars may have ended their lives in explosions so powerful they completely tore themselves apart, leaving no remnant behind at all. No neutron star, no black hole, just a chemical memory drifting outward forever. Even by cosmic standards, that's dramatic. You notice how the surrounding gas clouds respond. They're no longer pure hydrogen dreams. They're seeded now, enriched with metals, Everything heavier than helium earns that name out here. These new ingredients change how gas behaves. It cools more efficiently. It fragments more readily. The universe has quietly upgraded its toolkit. Historians still argue whether this chemical enrichment happened quickly and locally or slowly and unevenly across vast regions of space. From your drifting vantage point, it feels patchy, irregular, like seasoning sprinkled unevenly across a dish the universe is still learning to cook. Time slides forward again, unbothered by your observations. Clouds collapse anew, but this time they do so differently. The presence of heavier elements allows smaller, longer-lived stars to form. Stars that don't burn out in a cosmic blink. Stars that hang around. You sense the shift from recklessness to sustainability. There's a subtle emotional change, too. The universe feels less lonely now, more populated. Not crowded, never crowded, but layered. Generations of stars overlap, each one inheriting the material legacy of the ones before. You realize you're watching ancestry form, long before anything exists to care about it. A soft modern aside wanders through your thoughts. Every atom of calcium in your bones, every bit of iron in your blood, owes its existence to moments like this. Stars dying so future structures can live. It's oddly comforting, in a distant, sleepy way. You drift past the fading glow of a supernova remnant, watching it stretch thinner, cooler, quieter. What was once a single star is now a diffuse cloud, ready to become something else entirely. The universe isn't repeating itself anymore. It's iterating. You settle into that idea as you move on. This stage isn't about light or darkness, birth or death. It's about inheritance, about the slow accumulation of possibility. The seeds are scattered now, and the universe is ready to start assembling them into something that looks, at last, like a galaxy. You drift into a universe that feels busier now, though still unhurried. The raw ingredients are finally in place. Gas clouds are richer, heavier, more willing to collapse, and dark matter halos have grown broader and deeper, like invisible bowls waiting to be filled. This is where the first small galaxies begin to take shape. Not grand spirals yet, not elegant ellipses, but modest, clumsy collections of stars and gas learning how to stay together. You hover above one of these early structures, often called a proto-galaxy. It doesn't look impressive. In fact, it's a bit of a mess. Stars form in bursts, lighting up briefly, then fading, while gas sloshes around unevenly, tugged by gravity and heated by radiation. A grounded scientific fact settles in gently. The earliest galaxies were small and irregular, often containing only a few million stars compared to the hundreds of billions found in large modern galaxies. You watch gravity do what it does best: collect, hold, and occasionally lose its grip. Some stars escape entirely, flung outward by chaotic motions. Others settle into loose groupings, bound but restless. Nothing here is stable yet. The galaxy is more like a construction site than a finished building, with pieces constantly being moved, removed, or replaced. A quirky tidbit drifts past your awareness. Simulations suggest that some early galaxies formed, partially fell apart, and then reassembled multiple times, like the universe repeatedly forgetting where it put its own furniture. It's endearing in a cosmic way. You notice how dark matter quietly dominates the scene. Though it never shines, it outweighs everything else, shaping the galaxy's size and behavior. The stars and gas are just decorations on a much larger, invisible structure. You sense that without this unseen framework, these early galaxies would simply drift apart, unable to hold themselves together for long. Historians still argue whether star formation in these first galaxies was mostly steady or violently episodic, with long, quiet periods punctuated by intense bursts. From where you float, It looks irregular and impulsive, like creativity without a schedule. Time continues its gentle slide forward. Millions of years pass, then hundreds of millions. These small galaxies begin interacting with one another, drawn together by gravity's long reach. Some pass close and steal gas. Others collide outright, blending their stars into larger, more complex systems. Growth here is not neat or polite. It's cumulative. You feel the shift as galaxies begin to matter not just as isolated objects, but as parts of a growing cosmic network. Filaments of gas stretch between them, groups form, clusters begin to hint at themselves. The universe is no longer just making things, it's connecting them. A soft modern aside slips in. Even now, your own galaxy still carries remnants of this era, ancient stars whose chemical fingerprints trace back to these early, awkward assemblies. They are quiet elders, still orbiting, still remembering. You drift a little farther back, taking in the scene. The universe has crossed an important threshold. It's no longer practicing, it's building. These small galaxies may be humble, but they are the foundation for everything grand that will follow. You let yourself relax into that thought, watching the structures slowly stabilize, knowing they won't stay small forever. Gravity, after all, has learned a new trick. Not just clumping, but growing. You continue drifting, and the universe begins to feel more dynamic, more social. Those small galaxies you just watched grow are no longer content to exist alone. Gravity stretches between them like an invisible web, gently but persistently drawing them together. From a distance, it looks peaceful. Up close, it's a slow-motion ballet of immense proportions. You float alongside two galaxies as they approach one another. There's no sudden crash. Space is vast, and stars are tiny compared to the distances between them. A clear scientific fact settles into your awareness. When galaxies collide, individual stars almost never collide with each other. Instead, the galaxies pass through, their shapes distorted by gravity. It's less a car accident and more a careful blending of two fog banks. As the galaxies draw closer, tidal forces begin to stretch them. Long streams of stars and gas are pulled outward, forming luminous tails that arc gracefully into space. You watch these structures form over hundreds of millions of years, slowly enough that the word collision feels misleading. This is erosion by gravity, patient and thorough. A quirky tidbit drifts by. Some simulations show that galaxy mergers can trigger waves of star formation so intense they're called starbursts, briefly turning entire galaxies into cosmic fireworks displays. Even the universe, it seems, occasionally overreacts to social interaction. You drift through one of these tidal tails, surrounded by stars that have been gently evicted from their original orbits. They continue shining, unbothered, adapting to their new trajectories. Gas clouds, however, feel the encounter more dramatically. They compress, collide, and collapse, igniting new generations of stars. Destruction and creation blur together again. Historians still argue whether galaxy mergers are the primary driver of galactic growth or just one of several equally important processes. From your floating perspective, it feels like a bit of both. Mergers accelerate change, but they're not the only way forward. As time flows, the two galaxies spiral inward, losing energy through gravitational interactions. Their cores draw closer, orbiting one another like cautious dancers until they finally merge into a single, larger system. The original identities of the galaxies fade, preserved only in subtle motions and chemical signatures. You notice how the resulting galaxy is thicker, puffier, less orderly than its parents. The neat orbits have been scrambled. The system feels older somehow, even though new stars are still forming. Growth here comes with a cost. Elegance is temporarily sacrificed for mass. A soft, modern aside floats in. The galaxy you live in is on a slow collision course with a neighboring one, A reminder that even now, this process hasn't stopped. There's no need to worry. You'll be long gone and it will take billions of years, but the thought is strangely comforting. The universe is still doing what it's always done. You drift back, watching multiple mergers play out across the cosmos. Small galaxies combine into medium ones. Medium ones into larger still. The web of structure thickens. Clusters become more defined. The universe feels less empty, more interconnected. You settle into the rhythm of these encounters. No explosions, no panic, just gravity reshaping everything over unimaginable timescales. This is growth by accumulation, history written in overlapping orbits and stretched starlight. You float onward, knowing that from this gentle chaos, new patterns will eventually emerge, patterns with curves, symmetry, and a surprising sense of calm. You drift onward, and after all that slow chaos, something unexpectedly graceful begins to appear. The merged galaxies you've been watching start to settle. Energy redistributes. Orbits smooth out. The frantic stretching and pulling gives way to rotation, and rotation, given enough time, has a habit of organizing things into patterns. You hover above a young galaxy as it begins to flatten. Gas, unlike stars, can collide and lose energy, and that matters now. A grounded scientific fact slides gently into place. As gas cools and settles into a rotating disk, conservation of angular momentum causes it to spread outward and flatten, forming the thin structures that eventually become spiral galaxies. Physics, once again, prefers elegance when given the chance. You notice the disk forming slowly, like a vinyl record pressed over hundreds of millions of years. Stars already present continue on their scrambled paths, but new stars form within this rotating plane, inheriting its orderly motion. Over time, the chaos fades into a steady spin. The galaxy exhales, finding a shape that feels finished, at least for now. Spiral arms begin as subtle overdensities, barely noticeable ripples in the disk. They are not solid structures, you realize, but patterns. Waves of higher density moving through stars and gas. A quirky tidbit drifts through your awareness. The stars and spiral arms don't stay there permanently. They move in and out of the arms like cars passing through a traffic jam, briefly slowed, then released. You drift along one forming arm, watching gas compress as it enters the denser region. Compression triggers star formation, lighting the arm with bright young stars. The contrast is striking. Calm rotation, punctuated by glowing streaks. The galaxy has learned how to decorate itself. Historians still argue whether spiral arms are long-lived, stable features or temporary patterns constantly forming and dissolving. From where you float, they feel persistent but alive, never quite fixed, always subtly rearranging themselves. Time stretches on, and the spiral becomes more defined. Dust lanes appear, dark and sinuous, tracing the arm's structure. You sense a balance here, gravity pulling inward, rotation pushing outward, star formation adding energy, cooling taking it away. The galaxy isn't static, but it's no longer turbulent either. It has entered a kind of middle age. A soft modern aside drifts through your thoughts. This is the kind of galaxy humans tend to romanticize, pin on posters and name after everyday objects like whirlpools or pinwheels. There's something deeply satisfying about a spiral. It looks like intention, even though it's just physics being very patient. You drift farther out, taking in the full disk. The galaxy rotates calmly. Billions of stars moving in quiet synchrony. Compared to the earlier epochs, this feels almost domestic, predictable, comfortable. The universe, for a moment, seems content with what it's built. But you sense that not all galaxies follow this path. Some never settle into disks. Some are disrupted too often. Some grow too fast, too violently. The spiral is not a destiny. It's a possibility. You linger a little longer, letting the rotation lull you, the steady motion, the repeating patterns, the gentle glow. It all feels like the universe has learned how to rest while still moving forward. You drift on, leaving the graceful spirals behind, and you begin to notice that not every galaxy shares that calm, rotating elegance. Some are rounder, smoother, less expressive in their motions, like old stones worn soft by time. Others remain lopsided, asymmetric, or oddly shaped, refusing to settle into anything recognizable. The universe, it turns out, enjoys variety. You hover near a large, rounded galaxy, its light evenly spread, its stars moving in many directions rather than circling in a single plane. A solid scientific fact settles into your awareness. Elliptical galaxies typically form through repeated mergers, which scramble stellar orbits and erase disk-like structures, leaving behind smooth, spheroidal systems with little remaining gas. This is what happens when growth is relentless. Inside this galaxy, star formation is mostly over. The gas has been used up, heated, or blown away. The stars here are older, redder, and quieter, orbiting without much fuss. The galaxy feels settled, even sleepy. There's a sense of long memory in its motions, as if it remembers every collision that shaped it. A quirky tidbit drifts by. Some of the largest elliptical galaxies are thought to have grown by cannibalizing hundreds or even thousands of smaller galaxies over billions of years. Cosmic minimalism achieved through maximal consumption. You drift away and find something very different, an irregular galaxy, chaotic and asymmetrical, with no clear center and no obvious pattern. These galaxies are often small and easily disturbed, shaped by nearby neighbors or internal bursts of star formation. They feel youthful, unfinished, like sentences without punctuation. Historians still argue whether irregular galaxies are temporary phases on the way to more ordered shapes or stable forms in their own right. From where you float, they feel resilient, surviving not by settling down, but by staying flexible. You notice how environment matters now. Galaxies in dense clusters tend to lose their gas, stripped away by hot intergalactic plasma, while isolated galaxies keep forming stars for much longer. A soft realization settles in. Where a galaxy lives can be just as important as how it formed. Time passes, and the cosmic population sorts itself out. Spirals dominate quieter neighborhoods. Ellipticals rule crowded clusters. Irregulars linger on the edges, doing their own thing. The universe hasn't chosen a single design. It's experimenting continuously. A gentle, modern aside wanders through your thoughts. This diversity mirrors life in a way shaped by both history and surroundings. Some systems settle early. Some keep changing. Some burn bright and fast. Others take their time. You drift back and take in the larger picture. The universe now feels mature. Not old exactly, but experienced. The frantic building phase has slowed, replaced by maintenance, recycling, and long-term evolution. Galaxies are no longer just forming. They're aging. You let yourself rest in that idea. The cosmos has learned there's more than one way to exist, more than one way to shine, and more than one way to slowly, gracefully wind down. You drift inward now, toward the hearts of galaxies, where the light grows denser and the motion subtly changes. Even in the calmest systems, something powerful waits at the center, unseen but deeply influential. You don't notice it at first. You notice the way stars orbit faster than expected. You notice gas heating, brightening, swirling more tightly than it should. The center feels heavier, more insistent. This is where supermassive black holes quietly reside. A clear scientific fact settles into your awareness. Nearly every large galaxy appears to host a supermassive black hole at its center, with masses ranging from millions to billions of times that of the Sun. These objects don't dominate galaxies by sucking everything in, despite their reputation. Instead, they influence their surroundings through gravity and energy, shaping how galaxies grow and change. You hover at a respectful distance, When gas falls toward the black hole, it doesn't disappear immediately. It forms a swirling disk, heating up as friction and gravity do their work. The result is light, sometimes more light than all the stars in the galaxy combined. For a while, the galaxy becomes active, its core blazing as a quasar or active galactic nucleus. A quirky tidbit drifts past. Some quasars are so bright they can be seen across most of the observable universe, powered by regions no larger than our solar system. Tiny engines, absurd output. You watch jets of energy blast outward from the core, punching through the galaxy and beyond. These jets heat surrounding gas, sometimes preventing it from cooling and forming new stars. The black hole, paradoxically, can slow a galaxy's growth, acting as a kind of cosmic thermostat. Historians still argue whether supermassive black holes form before their galaxies, grow alongside them, or emerge afterward through mergers and collapse. The relationship feels intimate and unresolved, like two old friends who can't quite agree on who influenced whom more. You notice how the galaxy responds. Star formation tapers off. Gas becomes harder to keep. The system settles further into maturity. The black hole doesn't destroy the galaxy, it nudges it toward adulthood, whether it's ready or not. A soft modern aside floats through your mind. The black hole at the center of your own galaxy is quiet now, almost dormant, a reminder that these dramatic phases come and go. Even monsters need rest. You drift outward again, carrying the sense that galaxies are not just collections of stars, but self-regulating systems. Feedback loops everywhere, cause and effect stretching across thousands of light years. The universe feels thoughtful here, less frantic, more deliberate. The engines are still running, but at idle. You let that steady presence calm you as you move on, knowing that the centers of galaxies will continue to shape their destinies long after the bright fireworks fade. You drift farther out again, away from galactic centers and their quiet gravity, and you notice how the pace of the universe has softened. Star formation is no longer frantic. The bright blue stars that once dominated the scene are rarer now, replaced by longer-lived, gentler ones that glow steadily without much drama. Galaxies, like people, seem to slow down with age. A grounded scientific fact settles into your awareness. Across the universe, the overall rate of star formation peaked billions of years ago and has been declining ever since. Astronomers sometimes call that earlier era cosmic noon, when galaxies were at their most productive. Now, the universe is well past that lunch break, easing into a quieter afternoon. You float alongside a mature galaxy and feel how stable it has become. Most of its gas is already locked up in stars or has been heated beyond usefulness. Without fresh, cool gas, new stars struggle to form. The galaxy isn't dead, it's just resting, coasting on what it already has. There's a dignity to that, a sense of having done the hard work early. A quirky tidbit drifts by. Some galaxies are described as red and dead, a phrase that sounds harsh but simply means they're dominated by older, redder stars and form very few new ones. Even astronomers, it seems, occasionally indulge in melodrama. You notice galaxies gathering into larger families now, groups and clusters bound together by shared gravity. Inside these environments, interactions continue, but they're gentler, less transformative than before. The big shapes are already set. What remains is fine-tuning. Historians still argue whether galaxies fade primarily because they run out of gas or because their environments actively strip it away. From where you float, it feels like both forces work together, a slow closing of doors rather than a sudden shutdown. Time passes almost unnoticed. Billions of years slide by with little visible change. Stars age. Some swell and shed their outer layers. Others quietly cool. The galaxies themselves persist, long-lived structures in a universe that otherwise seems determined to change. A soft modern aside slips in. When you look up at the night sky, Most of the light you see comes from galaxies already well into this mature phase. You're not witnessing a beginning. You're catching a long, steady continuation. You drift back and take in the cosmic web as a whole. Filaments still stretch between clusters. Voids remain vast and empty. The universe feels balanced now, no longer rushing toward complexity, but maintaining it. There's a calm satisfaction here. The work of building is mostly done. What remains is endurance. Galaxies grow old together, sharing gravity, history, and time itself. You let yourself sink into that calm, aware that this slowing is not an ending, just a different rhythm, quieter, deeper, and surprisingly peaceful. You drift onward into the present-day universe, and something about the scene feels unfinished, in a comforting way. The grand structures are in place now. Galaxies spin, cluster, age, and glow softly against an ever-expanding backdrop. And yet, nothing has truly stopped. The story hasn't ended. It has simply slowed to a thoughtful pace. You hover near a galaxy much like the one you call home. It's calm, orderly, still forming a few stars here and there, mostly along its spiral arms. A clear scientific fact settles gently into your awareness. Galaxies continue to evolve today through minor mergers, gas accretion, and internal processes, even though the dramatic growth phase of the universe is long past. Change never disappears. It just becomes subtle. You notice faint streams of gas drifting in from intergalactic space, thin and delicate, like cosmic breath. These slow infalls can spark new star formation, keeping galaxies alive longer than expected. Growth, you realize, doesn't require urgency. Sometimes it just requires persistence. A quirky tidbit floats by. Astronomers have found galaxies so isolated that they've barely interacted with anything else for billions of years, quietly evolving in near solitude. Cosmic introverts, content with their own routines. Historians still argue whether the universe's accelerating expansion will eventually isolate galaxies completely, cutting them off from one another forever, or whether unknown physics might alter that fate. From where you float, the uncertainty feels gentle, not alarming. Even the universe doesn't know exactly where it's headed. You drift back and take in the full arc of what you've witnessed. From near-perfect darkness to glowing structure. From tiny fluctuations to vast rotating cities of stars. None of it rushed, none of it wasted. The long birth of galaxies turns out not to be a single event, but a habit. Gravity patiently shaping matter over and over again. A soft, modern aside settles in. The atoms that make up your body were forged somewhere along this journey, assembled by processes that took billions of years to unfold. You are, in a very literal sense, the universe taking its time. You linger there, suspended between past and future, and let the thought land. Galaxies are still forming, still merging, still aging. Even now, somewhere far beyond what you can see, new structures are quietly beginning their own slow stories. The universe doesn't hurry, and it doesn't need to. It has learned that given enough time, complexity will arrive on its own.